The questions that I have been trying to address in my work is this question of what role does the brain play in this accessing of non-local information? I mean, I'd say the majority of people would maybe, if they had some experience with information that they don't know how they knew, they would certainly not say that it's something that they can call upon at will and say, you know, I want this non-local information that I want to connect with person, and then it just happens. It's more something that for most people happens spontaneously, frequently happens in dreams, but not in the waking state, or it happens during these meditative states or transition states between waking and being asleep. So there's some, so we all have the potential to experience these things, but there's some people who seem to have these abilities to an extraordinary degree. And I wondered, well, what is it that's different about their brains? And one of the reasons why I was interested in autistic savants was that in autism, there are frequently, by definition, there are frequently disturbances in the abilities that we associate with the left hemisphere. And these children will oftentimes have, as a result of having deficits in left hemisphere skills, they'll frequently have extraordinary abilities that are right hemisphere skills. So when we look at some of the savant skills, one of them is visual spatial processing ability. There is someone who is nicknamed the human camera because of his ability to just fly over in a helicopter, just fly over Rome or London or some other major city for the first time, and only spend, say, 45 minutes doing that, and then go back to a room in which it's paper covering all the walls, and draw everything that he had seen in precise detail. I mean, getting every single building, the right number of windows in the right location, providing a perspective that was only possible from that bird's eye view that he obtained in the helicopter. And so here we have this extraordinary visual spatial ability, and in somebody who can barely speak, has very limited language skills. So there's this shift that we have also heard people talk about before when they're talking about psychic abilities. They say that they associate the right hemisphere with more intuitive ways of gaining information versus the left hemisphere being associated with more analytical or derived forms of information. So initially I was looking at it this way. I was also looking at what else is different about the brains. And in dreaming sleep, the right hemisphere is more active than the left hemisphere. And also the visual cortex is very active. But the other sensory cortexes, the other areas of the cortex are less active during dreaming sleep. And so during dreaming sleep, you know, why is it that we can oftentimes have a connection with somebody? There have been many accounts in which somebody has a dream that something happened to a loved one, or that somebody died, let's say, and then they find out that yes, that did happen, and it was at the time that the person dreamed it. And so that was also informing my theory building in terms of looking at these autistic children, because they also have very active visual cortex, but oftentimes have less activity in the frontal lobes. And this is something that's true for young children. And a lot of these experiences of psychic abilities are more common in children. And that's a time period when the frontal lobes, which are very analytical, they tell us what's possible and what's impossible. If the frontal lobes in a small child are not as hardwired into suppressing the rest of the brain. And so as we get older, our frontal lobes become more connected to the rest of our brain through a process of myelination, which makes the ability to transmit information from one end of the brain to the other much faster. So these small children have this brain pattern activity that's more similar to what autistic people have, and sort of oftentimes continue to express even into adulthood. So that was the model I was looking at. But then I started to think more deeply about, well, still, how is it? So that's just telling me what kind of brain activity is going on. How do we make sense of all of the data? How do we make sense of all of the data to try and understand what the brain is doing in relationship to consciousness? And what I realized is that we might be asking the question in the wrong way. And what I mean by that is that we're saying, well, how is it that the brain generates consciousness? Well, that is an assumption. How do we know that the brain is generating consciousness? What if the brain is instead our recording device, our means of navigating consciousness, that consciousness is something that instead is primary, and that the brain is merely responding to consciousness? We know that there's an association between consciousness and brain activity because we've got so much evidence for that if you change the nature of somebody's brain waves, make them faster, make them slower, that correlates with different conscious states. But it's a correlation isn't necessarily causal. It could go in either direction. So I started looking at the brain in a different way and looking at it from sort of standing back and looking at the brain as an engineer would look at a structure that you found and you had no preconceived notions about how it works. I started looking at the brain instead as being more like, let's say, our remote for our whole our whole television system or our internet, that whole communication system, that the remote has all these different ways in which we can access different types of programming, but the programming itself is not what's generated by the remote. And so I started thinking, okay, let's just look at it and see, is there any evidence that this kind of a model makes sense? And sure enough, I've found that if you look at the brain and as an electromagnetic organ, and you just put all of the neurotransmitters aside and you stop thinking of them as anything more than just part of the hardware and start looking at functionality, this model actually makes sense, and it enables all of these other phenomena that have been dismissed by science to be possible, because it's a very different way of thinking about the brain.